Okay, so here's a goodness fit question where the categories aren't equally likely. And My Open Math gave us this information this way, where it said, so we expect category A to have 10% or 0.1 of the 10% of the data, and category B to have 30%, and category C to have 40%, and category D to have 20%. Remember, to make those percentages, I'm just timesing them by 100. So 20% and 40%, etc., etc. So how do we get these expected counts here when we have this one-way goodness of fit table, a one-way table? So what I did is I set up the information a little bit differently. I kept those the same, but then I wrote the relative frequencies down in a column just as a way to keep myself organized. And then to calculate the expected value, I had to find the sum of all these categories. I had 108 of them. And then since 10% of them is supposed to be in category A, I went 0.1 times 108. And that's going to be my expected value. That's going to go right here, my expected frequency. Did 0.3 times 108, and 0.4 times 108, and 0.2 times 108. And that's how I filled in those columns. Okay, so now to calculate these squared residuals, that squared residual column, I calculated all those expected values. Remember, I did 108 times 0.1 to get the 10.8. I did the 108, which is the sum of those numbers, times 0.3 to get the 32.4, 108 times 0.4 to get that 43.2 number, and then 108 times 0.2 to get that number. Now, to get these squared residuals, remember what we're doing is we're doing this part of the chi-square test. We're doing the observed minus the expected. We're squaring that difference, dividing by the expected. So what I did is I did the 7, which is our observed, minus our expected. I got that answer. I squared that answer, raised it to the second power, and then I divided that answer by the 10.8, which is the expected. And that's where I got the 1.337-ish. Okay, same deal here. Observed minus the expected, squared it. Remember, hit equals and then square it, then divided by that expected value, and that's where I got that number. Okay, so on and so forth. So that's this column. Then to get the chi-squared statistic, we're going to take the sum of all those values we just calculated. So if you add up all the 4 of those numbers, you're going to get 4.832. So hopefully this will help you do this kind of problem.